This is the next homework video guide on limit problems, and in this homework video guide I need to solve a very special type of limit problem. So for this limit problem I am going to infinity, but now I have a square root within the problem. So I call this the highest power in the square root method, and in order to kind of solve these kind of problems, so we have to be very familiar with a few other algebraic properties, and I have them listed on the right hand side here. So we'll be using the square root of x squared a few times in this problem, but more importantly, we have to be very comfortable with using the absolute value. Now, the absolute value basically has two properties. It can be x or negative x, and it really depends on where the limit is going. So if you're going to positive infinity, you will use a single x for the absolute value, and if you're going to negative infinity, then you will use negative x for the absolute value. And throughout this problem, we also have to know how to deal with a few of these radical properties as well here. So I will refer back to the properties here on the right hand side to help me throughout this problem. And if I go back to this original problem here, one thing that you have to recognize right away is, yes, the limit is going to infinity, and you have this square root within the problem there. So those are two indicators that should tell you that you need to use a brand new method for this problem. And I call this method the highest power in the square root method. Now, if I look inside the square root, the highest power is x squared, right? So I like to write that as the square root of x squared. All right, so that's the highest power within the square root. Now, what I'm going to do now is I'm going to rewrite the first part of the limit problem here. So this is the limit as x goes to infinity, and on the numerator I have x plus 3. Now, I'm going to divide every single term in the numerator by the square root of x squared. And then on the denominator here, I have the square root of x squared plus 1. And then I have a separate plus 2 on the outside there. And I will also divide these terms by the square root of x squared. Alright, so although this looks algebraically different, it looks different from the original problem, but since I'm dividing every single term by the same thing, mathematically it's the same problem here. Okay, so the next thing we're going to do is I see the square root of x squared there, I see it over here, and I see it over there. Let's go to our little cheat sheet here on the right hand side, and the very first thing that I want to take note here is that the square root of x squared is equal to the absolute value of x. Alright, so we've talked about that in class, and we've done that through some very simple mini investigations in class as well. So what we're going to do now is we're going to replace all of these, the square root of x squared, with the absolute value of x. Okay, and then if I go ahead and take a look at the absolute value of x over here on the right hand side, we know that the absolute value is either going to be x or negative x, and it depends on if we're going to positive infinity or negative infinity. Well, in this question here, we're going to positive infinity, right? So what that means is we're going to replace all the absolute values of x with just a single x, right? So all these absolute values of x, they now get replaced with a single x because we're going to positive infinity. So I'm going to erase that, that, and that, and I will just write a single x here, a single x there, and a single x there. So that's looking pretty good. Now for this part of the problem here, this radical divided by a radical, well, if I go back to my little cheat sheet here, let me erase all this. If you have a radical divided by a radical, you can write that as the square root of a over b. Okay, so if I apply that to this particular problem here, let me erase this, and let me just draw a bigger radical sign, and we're just dividing that by x squared. And if I do that, I can now do this, where I can divide each term by x squared. Okay, so a lot of algebraic properties happening within the problem here. Okay, let's go ahead and keep on simplifying this. So if I write my next line here, this will be the limit as x goes to positive infinity. Now, if I have x over x, that's simply going to be 1. So that's 1 plus 3 over x. And that's being divided by the square root of, okay, well, now we have x squared divided by x squared, right? So x squared divided by x squared is simply 1. And I have the plus 1 over x squared, right? And then that's all under the brackets there. Plus just 2 over x. All right, now this is looking pretty good. Now this is very similar to solving the limit problems that we had in the previous homework section. I will now do a direct substitution step here. So anytime I see an x, the x's will be replaced with positive infinity, and that basically means that this will go to 0, that will go to 0, and this will go to 0. And the only thing that survives is this 1 on the numerator and this 1 on the denominator. So this is really now just 1 over 1, and 1 over 1 just equals to 1 there. So that's your final answer for that particular problem there. Okay, so before I continue on with the next question here, I just want to show everyone a visual of what's going on in this particular problem here. So the question, this particular question was the limit as x goes to positive infinity, and we had x plus 3 on the numerator, all divided by the square root of x squared plus 1, and then plus the 2, right? So remember, when x is going to infinity, I mean, that just means what happens if I go forever to the right-hand side. So this is basically a horizontal asymptote, and basically this height that we level off at has a value of 1, which is what we found, right? So the horizontal asymptote for this particular problem is 1. Okay, so that's what our answer means in terms of a graphical answer here as well. Okay, let's move on to the next homework question here. So this is the next homework question here, and what I notice here is that x is going to negative infinity, so that's an indicator that this is a very special type of limit problem. And then I see the added square root sign, so this is now the highest power in the square root method, here, and the highest power that I see in the square root is still going to be this x squared, right? So the highest power in the square root is root x squared. Okay, and now when I write my limit statement here, this is the limit as x goes to negative infinity, and now I'll write the original problem as negative 3x plus 1 on the numerator, and I'll divide every single term in the numerator by the square root of x squared, divide that by the square root of x squared, and then on the denominator here we have this whole square root of 4x squared plus x, and that's going to be divided by the square root of x squared there. Okay, so the idea is, although this looks completely different from the original problem, the fact that I'm dividing every single term in the numerator and the denominator by the same thing, this means that it's mathematically the same problem. Okay, let's deal with this part right here. Okay, so what is the square root of x squared equal to? Okay, so if I go back to my cheat sheet here, the square root of x squared is equal to the absolute value of x, right? So let's erase this and this, and now we have the absolute value of x, right? And then what does the absolute value of x equal to? Well, here's the absolute value of x, and this particular problem we're going to negative infinity, right? So if I'm going to negative infinity, all the absolute values of x get replaced with negative x, and this is going to help me solve the problem. So I need a negative x there and a negative x there. Okay, and now we should deal with this ugly situation here. I have a square root divided by a square root, so now I need to use this radical property here, where if I'm dividing two square roots, I can write the whole thing as a bigger square root with the fraction inside. Okay, so how do I apply that here? Okay, well, let me erase this, and let me erase that, and let me just write a bigger square root sign, and that's being divided by x squared. Okay, and what does that really mean? Well, what that really means is I can divide these individual terms by x squared. Okay, sorry, my square root sign is not really straight here. I'll try my very best to straighten that out. Okay, and now we're pretty good. Let's go ahead and just take one more line to simplify all this. So I have the limit as x goes to negative infinity. Okay, now I know that this x and this x will cancel off, and this negative 3 divided by that negative 1 is going to be a positive 3, so positive 3. And then I have a plus and a minus sign, so that's going to be a negative 1 over x. And that's going to be all divided by, okay, and then I have a square root sign here. And I guess this x squared and that x squared will cancel off, giving me just a 4 on inside the square root. And when I have this x and this x divided by x squared, that's going to be plus 1 over x. Okay, this is looking pretty good now. Now, if I plug in negative infinity into the denominators there, those will all just go to 0. And then what I'm left with now is just 3 divided by the square root of 4, which is going to be 3 divided by 2. So that is my final answer for that particular problem there. Okay, and before I move on to the next question here, here's another visual of that particular problem here. So the question was the limit as x goes to negative infinity, and the problem was negative 3x plus 1, all divided by the square root of 4x squared plus x. And we're going to negative infinity, so we're going forever to the left, and it turns out that the height that we approach is going to have a value of 3 over 2. Okay, so that's roughly around here, so about 1.5. So basically the horizontal asymptote in this problem is 3 over 2. Okay, so hopefully that graph can help you understand what the answer means for this particular problem here. All right, and then we'll just continue doing more of these particular problems here. So once again, we have the limit as x goes to infinity, but now I have the square root there, right? So this time the square root is on the numerator, and it doesn't really matter where the square root is because we're looking for the highest power in the square root, and the highest power in the square root is still x squared, so I'll write this as root x squared. And now I'll rewrite the original problem as the limit as x goes to positive infinity, and then I'll rewrite the original problem as x squared minus 1 plus 3, and then I'm going to divide that by the square root of x squared, and I'll divide that by the square root of x squared. Okay, and then if I continue on the denominator here, I have a 2x here, and then I'll divide that by the square root of x squared. Good. All right, so this is looking pretty good here. Once again, this definitely looks different from the original problem, but since we're dividing every single term in the numerator and the denominator by the same thing, it's mathematically the same kind of problem. All right, so let's deal with these terms first. Okay, so as mentioned throughout the video, the square root of x squared is equal to the absolute value of x, right? So I'll erase this and I'll erase that. And I'll replace this now with absolute value of x, absolute value of x. And this problem we're going to positive infinity, right? So the limit is going to positive infinity, and if using my little cheat sheet here, if the limit is going to positive infinity, then the absolute value is replaced with just a single x, right? So I'll erase this and I'll erase that. This becomes a single x and a single x, which is good. And now I have this radical divided by another radical, right? So I can use this second property here, where a radical divided by a radical is basically the square root of the fraction. Okay, so if I just erase this and just maybe write a bigger radical sign here, this is being divided by x squared. And to be more precise now, basically what that means is this is being divided by x squared, and that's being divided by x squared, right? So these are all algebraic properties here. Okay. Let's go ahead and now write our next line here. This is the limit as x goes to infinity here. And now I have the square root sign, and x squared divided by x squared is simply going to be 1. And now I have minus 1 over x squared plus 3 over x. I can't do anything there. And then that will all be divided by, well, this x and that x will cancel off. So now I just have a 2 on the denominator there. Okay. So here we go. I really can't simplify this limit problem any further now. So if we go ahead and apply a direct substitution step here, all these x's will be replaced with positive infinity. So this goes to 0, and that will go to 0. So now you have the square root of 1 divided by 2, and the square root of 1 divided by 2 is just going to be 1/2. All right, so that's your final answer for this particular question here. And that's it. So I will not provide a graph for that one there, just because I think we kind of have an idea that these are basically questions that are asking you what is the horizontal asymptote. Okay, let's take a look at another question here. Once again, x is going to negative infinity, and I have a square root here. So this one's kind of nice because it's a little bit different. So this is the highest power in the square root problem still. And we'll notice that the highest power is now x to the power of 4, right? So the highest power of the square root is x to the power of 4. All right, so if I write out my limit statement here, the limit as x goes to negative infinity, I can write this as the square root of 4x to the 4 plus 3x squared. And I will divide that by the square root of x to the 4. And then we also have denominator here of just x squared minus 4x, and we're going to divide that by the square root of x to the 4 and divide that by the square root of x to the 4. Okay. Now this one's a little bit different because we really can't use any of the limit properties just yet from what we had, but I do want to say that when you have the square root of x to the 4, and if I want to simplify this, there's really like an invisible 2 here as your index, so this is really equal to x to the power of 4 divided by 2, and this is now equal to x to the power of 2. So what we're saying now is anytime we see the x to the power of 4s here, we're going to replace those with just x to the power of 2, right? So on the denominators here, I'm going to replace those with x to the power of 2, and I'll replace this now with x to the power of 2. And over here on this particular radical there, I can still apply this second principle there where the entire radical could be written as a bigger radical with a over b inside the radical. So if I apply that to this particular problem, it's kind of like we have the square root of this divided by x to the power of 4, and then if I simplify that even further, it's the same thing as this, where I divide by x to the power of 4 and divide that by x to the power of 4. Okay, so this is looking pretty good now. Now we can go ahead and start really simplifying this so that I can jump to my final answer here. So this is the limit as x goes to negative infinity, and I have the square root now. And I see that this x to the power 4 and that x to the power 4, those just cancel off. And now you just have a 4 inside plus, and then x squared divided by x to the power 4 is going to be, well, we're going to have more x's on the denominator here. We're going to have 2 more x's on the denominator. And then we'll divide this by, okay, well, x squared divided by x squared is simply going to be 1 minus, and then x divided by x squared there is going to be an x on the denominator, right? So 4 divided by x. Okay, so now we can go ahead and plug in negative infinity here. So if I plug in negative infinity there and there, basically I guess this would go to 0, that would go to 0. And now you just have root 4 on the numerator and just 1 on the denominator there. And root 4 divided by, root 4 is going to be 2, and the denominator will be 1. So 2 divided by 1 is going to be 2. So that's your final answer for that particular question there. Okay, great. I think I have one more question here.